or you can say a new lesson that is the part-wise graphing. What I mean to say, that was exactly the problem from what I have got. So let's see. This is the topic of the day. So let me just show it. Okay. I'm sure that you can see the screen now. Please read it.
Okay. Graph piecewise defined functions step by step.
So here we will learn different techniques and we will graph few functions that are the part wise when the outcomes are more than one for the different domains of function, and then we will have to draw the graph piecewise. So let's see. uh, this is the okay. Please read this one.
Sure. A function that requires more than one formula in order to obtain the given output.
More than one formula. Then look at this.
For example, in the toolkit functions, we introduce the absolute value function fx, f of x is equal to x, absolute
X
value of
mod,
x.
X absolute X, or the modulus of X. So here, as you know, that in the modulus, the positive and negative, both the values are included. So
Okay.
yes, please go on.
With the domain of all real numbers and range of values greater than or equal to 0, absolute value can be defined as the magnitude or the modulus of a real number value regardless of sign.
Regardless of sign. So
This is a distance from 0 on the number line. All of these definitions require the output to be greater than or equal to 0.
greater than or equal to 0, because we are taking the modulus value, and as you know, the distance on the line cannot be negative.
Right.
Okay, please read this one.
All right. If we input 0 or a positive value, the output is the same as the input. F of x is equal to x if
X
um,
is equal or
if
greater?
x is yeah if x is greater than or equal to 0.
0. So we will get the both the values equal, the function and its output. Now let's see, then the second condition is if,
If
please,
if we input a negative value, the output is the opposite of the input. So f
yes,
of x is equal to negative x if x is less than 0.
less than 0. We are putting the negative value. So please, because
Because this requires two different processes or pieces, the absolute value function is an example of a piecewise function.
piecewise function. So because here every time we are getting the two outputs, one for the negative value and the second for the positive value. So this is what we can say the basic and the best example of piecewise function. Now let's see how can we graph it. Please read this one.
A piecewise function is a function in which more than one formula is used to define the output over different pieces of the domain.
Yes. So more than one formula. The function is one, but it is defined in two or three ways, because for each and every domain, the value of the function is different from each other. So that's why we will have to draw the graph piecewise, because we are taking one domain and we are putting it, so we are getting the different outcomes. And similarly, when we are putting the second domain, so we have totally different outcomes. So in this way, we will have to draw the piecewise, what I mean to say, function, and it has more than one formulas and for each and every domain. And when we are drawing this and we are graphing these type of the functions, so we are getting the discontinue, what I mean to say, not the same graph, we are getting different type of the graphs, but they are joining together in a different way. So let's see how. Please read this one.
We use a piecewise function to describe situations in which a rule or relationship changes as the input value crosses certain boundaries.
Boundaries. Now let's see. It's a very good, what we can say, explanation. Just to for the easy understanding, we can say that when we use piecewise functions to describe situations, those situations in which rule or relationship changes all of the sudden as the input values crosses certain boundaries. So the restrictions are there. When you are crossing this limit, this domain, you will get this output. If you are crossing this, you will get this. If you are below that bracket, you will have to pay this. So many conditions are imposed, and for each and every domain, we will have to define a different function, and this way we are getting a different output. So that's why we can say that these are the piecewise function, and if we are graphing these piecewise functions, so definitely we are getting the different graphs for the different domains. So that's why I have selected this lesson from your problem, that there was the one screenshot where you are asked to find the piecewise graphing of the situation and piecewise solution of the graph. So that's why I'm sure that at the end of this slideshow, we will be in a better position to find out all those piecewise graphing and the solutions of all those piecewise function. I'm sure that you are with me.
Right.
Okay. Now let's see what is next. For example, now let's see, it's a very good example. Please read this one.
Okay. For example, we often encounter situations in businesses for which the cost per piece of a certain item is discounted once the number ordered exceeds a certain value.
Yes, so it's a daily that if you are getting two, get one free. If you are getting this, if you are shopping this amount, you will get these discounts, and so many other things are relevant to this. So we encounter situations in daily life. The cost of price of certain. If you are ordering a big quantity, so you will get the bigger discount, and similarly there are so many situations. So each and every time we will have to make the calculation slightly different. We will have to use the different format of the calculation. So that's why the function is the same, but that the outcome is coming different in this way. So this is a good example. Now let's see once again. There is one more, that is look at this. Please read.
Okay. Tax breakers, tax brackets are another real world example of piecewise function.
Yes. So this is what we can say, that if your income is up to this limit, you will get the different calculation. If you are crossing that limit, if some additional money or income is there, so you will have to pay some more tax in different ratios. So these are all the, what we can say, the piecewise functions of our daily dealings. So that's why these are the examples, and you can see a lot of things, a lot of calculation, and a lot of professional peoples are making the calculation in different way, and that's why they are called the expert of all these fields. Anyhow, we are just keeping the things simpler and easier. So let's see. Yes, please read this one.
For example, consider a simple tax system in which incomes are up to 10,000 are taxed at 10% and any additional income is taxed at 20%.
Yeah, yes. So this was the example that up to this limit, there is a different rate, that is 10%. And when you are crossing this, so you will have to pay extra. What I mean to say, the percentage becomes the twice of this. But if you are remaining within this limit, so you will have to pay this. The calculation is slightly different for that. And if you're crossing that, so this limit you are getting what we can say, the rate is doubling. So Please read this one.
Sure.
Tax
The tax on a total income, S would
S.
be 0.01 S if S is less than or equal to 10,000, and um 10,000 plus 0.2 times S minus 1, sorry, S minus 10,000 if S is greater than 10,000.
So that was the mathematical interpretation of that example. So if you are crossing this limit, so if you are retaining this either less or equal to this, so you will have to get this simple calculation. What I mean to say, 10,000 plus 0.2, and if this is for the 0.1, if this and if you are have additional amount, so this will be calculated in this way, that 0.2 and here 0.1, 10% and 20%. So this will make a lot of difference if your income is crossing this limit of $10,000. So that's why this is called the piecewise function, where
Your
uh,
voice cutting out really bad. I don't know if you can hear me.
yes, please. Hello.
Oh, okay, there we go. Your voice was like sounding really weird. I think
Okay.
it's fine now, I think.
Okay. Anyhow, but you can see all these things which I am saying visually. These slides are very much prominent to you, and you cannot miss any bit of the information. So each and everything is written over here. But I am trying my best to just to make the sound quality also better. So anyhow, if you are feeling any discomfort, so you can interrupt me. So I will try to make the things better. Anyhow, we are just continuing this. So a piecewise function is a function in which more than one formula is used to define the output. So this is the what we can say the shortest and easy to say, easy to understand definition. So whenever you are coming across this piecewise function, so you must say a function which has more than one formula, more than one formula. And definitely if the formulas are different, so you are getting the different outputs, and those formulas are applicable for the different domains. So that is the detail. But for the easy understanding, a piecewise function is a function in which more than one formula is used to define the output. So that's why so simple is this one. I'm sure that you are getting the idea right now what is
Right.
piecewise. Anyhow, look at this
Yeah.
one. Each formula has its own domain, and the domain of the function is the union of these smaller domains. What I mean to say, it's very much what we can say that a function is defined in two or three ways. And due to this reason, because in each and every domain, the calculation or formula is becoming slightly different from that. But overall, when you are calculating
Right.
making the calculation with the different formulas for the different domains, so at the end you are getting what we can say that is the union of the smaller domains. What I mean to say, you will see at the end of this that there is a function we have traced it piecewise. Then after all, we are just making all these pieces together, so those are becoming the unions of all those pieces, and we can join those pieces to get the overall picture of that function, overall graphing of that function. But anyhow, the main idea behind this piecewise function is that there are different formula for the different domains and for the different conditions and different outcomes. So let's see, we will do the example also. We notate this idea like this. So let's see, look at this. So we are just coming to the mathematical form now, that a lot of things we have discussed in what we can say theoretical way. So this is the just functionality or the practical, what we can say, the more mathematical part is just coming now. So let's see fx. I'm sure that now my voice is better than. Are you listening me?
Yeah, I can hear you.
Is there any disturbance, or if you are not getting? So I'm sure that I am audible now.
Yeah, now I can hear you.
Okay,
Yep.
okay, okay. So fx, this is a function. So it can be defined in three ways. What I mean to say, the function is the same. Formula one is formula one if x is in domain one. So here we have the one definition. If we have
Okay.
the one domain, the domain is different, the formula is different. In the center, this is the second choice. We will have to use second formula if x is in the domain, second domain. So if x is bracketing somewhere in this domain, so we will have to change the formula. Here, fx will become according to this. And similarly, this function fx will become this one, the formula 3. We will have to use formula 3 if x is in domain 3. So three domains, and we have three formulas. So if you are putting or selecting any value from this domain, so you will have to use this fx is equal to this. And similarly, if your domain is all of a sudden changing, so you will have to utilize the second one. And if your domain is now you are selecting different values which are not in first and second domain, so you will have to use this definition of the same formula. So formula is one, but it is defined in three ways with the help of three formulas, because each and every domain demands for the different type of the
Yeah.
mathematical calculation. So we will see the practical example also, but that is what we can say, that is the most simplified form of that discussion that we have gone through so far. So this is the best way to define in a mathematical way, that the same function having different formulas with different domains, and definitely different formulas will yield you the different outcomes. So let's see. So in piecewise notations, the absolute value of function is. Now from here you can say that you are using a function that is the absolute value of x. So that can be in two types of the calculation. So we can get the value x, the positive x, if x is 0 or greater than 0. And similarly, the absolute value, so you will have to use this minus x, because now x is less than 0. So negative value for this and the positive value for this. So this is the, what we can say, the mathematical format, that if you are just considering a function that is the absolute value of anything, x is anything, that may be a long function, that may be equation or whatsoever that is. So we will have to consider all the time one for the positive value, that is x, that is the outcome of that formula, and the second one is the negative, if we are selecting, if the domain is given of all those negative numbers. So this is what we can say, the exact example of piecewise function. Now let's see, one more example is given a piecewise function, write the formula and identify the domain for each interval. So this is the, what we can say, the foremost requirement, that if a given piecewise function is given, so what we will have to do, the first and the key step is that we will have to write the formula. And this formula is according to the identification of domain for each interval. So we will have to observe the domain. If domain is from this interval, so we will have to write a different formula. If domain is slightly different of the previous one, so we'll have to make the all those arrangements, all those shifting in the formula, just to accommodate the other domain. And definitely each and every domain have different type of the intervals, and we will have to locate on the graph, or we will have to calculate by using the different formulas. I'm sure that you are getting this, that what is
Yeah.
the a piecewise function and how can we write the formulas. But anyhow, now let's see. Identify the intervals for which different rules apply. So that's why, as the income tax example, that if you are coming in this bracket, so you will have to be in a different way, your calculation will be different. If you are getting this falling in this bracket, so is in this domain, so your calculation, what we can say, the formula is slightly different of that. So what we can say, that first of all, that is the piecewise function or graphing is totally depending upon the domains. So if we are changing the domains, so definitely you are getting the different values. If we are changing the domains, so we will have to make shift of all those formulas. There may be a slight shift, or there may be a total completely, that is a new formula is coming over there for that domain. So we will see that practically. We will solve the examples. So let's see, we are just moving to the next slide. So first is determine formulas that describe how to calculate an output from an input in each interval. So
Okay.
as I was saying, the first step is that we will have to find out the formula, that which formula is best fitted for the different values, for the different outputs, for the different interval, or for the different domains. Use the basis and if statements to write the function. So what I mean to say, that if your mathematical formulas are given, so the statements are different, and you will have to put the different brackets. And if the statements are given, so you will have to write the function in different statements. Now let's see the graphing of a piecewise function. So here you will see the exact example, that when we are graphing a piecewise function, so what we'll have to do. So that was actually the problem, and that was a screenshot. But anyhow, we are just solving the example to make the clear understanding of that. So sketch a graph of the function. Now we are just going to draw the graph, and the function is given, and we will see that what is the nature of this function, and what are the different domains, and how we are getting three different type of the graphing of this, that is called the piecewise. Now let's see, uh, this is the function. Now you can see that fx is defined in three different ways. One is the x square if x is less than or equal to 1. If our domain
Right.
is less than our fx ABC from domain. So I am
Right.
putting this dot circle is fit and less than one. We have x 0, or when doing x 1, so 1 moving up. So if I'm putting minus, I'm getting 1 minus 2, getting plus 4. Are you getting this? So all char is 1. This putting 1, so you will get 1. If you're putting 4, so you will get 4. You will get 4. If you're putting 3, you will get 9. I'm sure they will. And it's
Right.
so this is did because input. So that's why X circle with a filled circle. So if then equal 1 arrow, so you are getting, and next way to again, so this is arrow and so 9 is where here. So stuff will go up sky. This is the you are mid times B part also. So our domain in this. So we will put this in. This what we can see it's open and this is open in this order. So like this. So this is this one increase and double it will circle at the end. So this one, right? So this each of the graph values you get 3. So but this graph is the smaller of graph with the growth, and it was starting from here and going in the size. So that's the part. That is this one. That is now he written is a great. So every time you're getting, so whatever the other than 2, 3, 3, 4, 5, because there is only the one side of the grid, two side elements are not given. Still, this thing cosine from 2 because it is 2. So set loaded 2. So we have the open circle at the big going 3 and 4 and so on, and this is going to up in the sky. Am I right?
Right.
Okay, so this is the third graph.
Oh,
Okay, so but this was just like that. This is has been defined in three different domains, and this three domains between these 2 points, and this is f x x greater than. What is the complete format of that? So I just put So this was what.
would it, like, what do you mean? Like, what was this? Like the first part?
You can see.
That was square x was less than.
And this in also my
Okay.
and have a close look at this. Not that. The
That's
second piece,
three.
it's a clear,
Yeah.
clearly shown over here. The first one starting here, loading one, and up in the sky. And that is third one, and that's
Right.
shown over here to that. So, see, from where, please read.
Regardless of the solution, note that graph does not it does pass the test even at x.
That's the one.
The solution be 1, 3 and 2, not graph of n. Though
Yes, that's by you. It's this graph is one. You are, I'm sure that you don't have that. I'm just going to see 2x minus plus percent 12. You have to start these both are the circle,
yep,
open
because
circles.
yeah.
Yes, and so you will put those values in this one, and you will draw the on grapher. I'm sure that you draw first putting this. You will get one, so you can. And if you are just moving to this three, so when you are putting three, six, three there below open circle. Side is one and I think to put the open circle at the four. So this
Okay.
was there is no problem. So that's why. And one thing, the last thing, that is the last, just so for a few seconds, what I mean to say that it's a weekend. So please send all those problems of your book also.
Okay, I
What
will
I'm
do that.
saying. So please note down this if you are not, because this is a weekend, I will get the time to solve all those problems. And if there is any possibility that if I can get the soft version of that, or if I can get the screenshots of all those problematic areas, so I will be in a better position to solve all those things at the appropriate level. What I mean to say, I will have to check the level of difficulty from the book,
Yeah.
so I will be in a better position. Otherwise, if haphazardly I am just going, so that may be a difficult way, or what I'm sure that may not be matching that level. So if there is a possibility, so you can send the soft version, e-version of that book, or if you can send the screenshots of all those problematic areas, so please do it. So this will be once again, as we were today we are talking about that are so many problems in the SAT paper also, these type, where you will have to
Right.
nominate the domains, somewhere you will have to find the function. So lot of problems, I will send you all those problem with the solution, which are just like that. So this is what we can say, the two-way benefit for you. One is for your academics, which is being now continue either online or uh, physically, and the second is that you are also getting the understanding for the SAT. So
Right.
if you are just sending me the problem, so that will be the two beneficial ways at one, two in one. Anyhow, thank you very much. So it's a time to say goodbye, Allah Hafiz. So thank you very much.
All right.
After the long weekend, we will meet again on Monday.
Okay.
Thank you very much.
Allah Hafiz.
Allah Hafiz.